Hello and good morning, good afternoon, good evening, depending on what time you watch this video. This is yours truly, Professor Ship, and I wanted to go over how to draw chemical bonds. I'm going to keep this one short and sweet and to the point because here's the thing. The way you do these chemical bonds and the way you draw them out is all based on how well you know the periodic table. So what you're going to find on your chart on the screen is a purple part. Those are your metals. The green part where that little staircase is, those are your metalloids, meaning they can go both ways. They can either become a metal or a non-metal, which brings me to the yellow section. Those are your non-metal elements. So we're going to go ahead and get into this information so that you guys can be successful in drawing out these chemical bonds. Now, this video is going to be done in two parts. I'm going to show you part one, how to even use the periodic table to know where your bonds are located. And then part two, I'm going to show you how to start drawing out these bonds, okay? So here we go. Notice that you have 18 groups. The groups are identified by the group numbers that you see 1, 2, groups 3 through 12, 13 through 18. The numbers are at the very top. But what you want to keep in mind is that those group numbers indicate the number of valence electrons. Now, you may have read that somewhere in your chemistry book. You may have heard that somewhere on these internet streets, and you're probably wondering, what is a valence electron? Well, valence electrons, ladies and gentlemen, deals with what's happening to the outer shell of your element. So let me show you what I mean. If I look at group one, I know that all the elements are only going to have one valence electron in its outer shell. When I talk about outer shell, we're referencing an example like this. You may have seen an image like this here, where in the very beginning you have two, and then on the outside it continues on. You may have heard of this in like your anatomy and physiology classes. You've seen this somehow, some way. This is what they're referencing. This is what they're talking about. So I'm going to show you all how to make that make sense, okay? So in group one, those elements have one valence electron in its outer shell. Group two have two valence electrons in its outer shell. We skip groups 3 through 12 because some of those elements have more than one charge. If you recall, we talked about this in your chapter based on writing chemical formulas. Some of those elements have more than one charge when it comes to writing out their chemical formulas. So we don't use valence electron bonding with groups 3 through 12. So we actually skip this section right here, okay? Now, when we get into groups 13 through 18, you drop the one off. And by dropping the one off, that tells you how many valence electrons are in its outer shell. So that means group 13 would have 3 valence electrons, group 14 would have 4, 15 would have 5, 16 would have 6, 17 would have 7, and group 18, you guessed it, has 18. But let me go ahead and give you all the visuals so you can see what I'm talking about. All right, so here we go. I'm going to write down what I just said. And when I say VE, we're talking about valence electrons, okay? This is going to make sense for you in a second. Group 2, 2 valence electrons. Remember, we skipped groups 3 through 12. And then when you get to groups 13, 14, 15, 16, 17, and 18, you are to drop the 1 off, okay? You drop the 1, and then that tells you that all the elements in group 13 have 3 valence electrons, group 14 has 4, group 15 has 5, group 16 has 6, group 17 has 7, and group 18 has 8 valence electrons. Now you're probably saying, well, what does that mean? Like, how am I going to write that down? Valence electrons. So let me show you, okay? I'm going to give you a clear-cut example of how to draw those out. All right, so let me go ahead and explain to you how to do the valence electron, okay? Using your periodic table, here we go. All right, so on your periodic table, you have an example of elements that are in group 1 having one valence electron. So that means when I write out the Lewis structure, which means using those valence electrons, I know that all the elements in group 1 would have one. So if I look at lithium, for instance, and it's in group 1, I'm just going to put one little dot there. That represents one valence electron, okay? If I go ahead and look at sodium, sodium is in group 1. Again, it only has one valence electron. Potassium only has one valence electron. In other words, in order to draw out a chemical bond between two elements, two or more elements, you have to determine how many valence electrons each element is going to contribute to that process. Okay? So if I look at, let's say, group 2 elements, how many valence electrons do they have? How many valence electrons will they be contributing? 2. So let me go ahead and draw it out so you can see. Beryllium will contribute 2. And some books will say you can pair them like this, where I can put them together, or you can have them separated like this over here. Okay? One dot on the right and one dot on the left. That's fine. It doesn't matter how you do it, okay? As long as you know how many valence electrons each of them are going to contribute. Magnesium is contributing 2. Calcium is contributing 2. So if I ask you what other element has the same number of valence electrons as magnesium or calcium, all you need to do is look inside the group number and pick any of those elements. Now remember, we're skipping groups 3 through 12, so we're going to go ahead and go straight to group 13. Now, when I look at group 13, I see that all those elements there have 3 valence electrons. So that means when I pick, let's say, aluminum, okay, I'm going to have one on the right, one at the top, and one on the left side. But again, ladies and gentlemen, you could put 2 together and then one at the very top. That doesn't matter in terms of how you arrange them. But what we don't want you to do is put 3 together at the same time because we do not know if this is going to be a triple bond. That's something you will learn about later in this chapter, okay? So again, when you look at group 13, any element that you choose, whether it's gallium, indium, boron, any of those elements, they're going to contribute 3 valence electrons. So that means I will be having 3 dots around it. Either you can pair the first 2 together and then have one solo, or have all 3 of them solo. But you never want to do it like this, where you're putting all 3 together, okay? It only works for having 2 as a pair, not 3. Unless you know for sure you're going to have a triple bond. And again, you won't know about that until later in the process. Now, if we look at group 14, all those elements in group 14 will be contributing how many valence electrons? And if you guessed 4, you are correct. So that means if I draw carbon out, I can start off with carbon having 1, 2, 3, and 4 valence electrons. Okay? Remember, I can pair them together by putting 2 on the right and 2 on the left. I can put 2 on the top and 2 on the bottom. Like, the way you can do it is limitless. Okay? So I don't want you to overthink that part. Just know that they will either be individualized or paired together. Okay? You can also pair 2 together and leave the other 2 unpaired. Because what happens is when you bring the other elements to form this bond, they're going to fill in the gaps and make the middle element whole. Now let's go ahead and get into nitrogen. All the elements that are in group 15 are going to contribute 5 valence electrons, okay? 5 valence electrons. So let's go ahead and show you that example with group 15. So here you've got nitrogen, and it has 5 valence electrons because it is in group 15. So this is 1, 2, 3, 4, and 5. Now remember, you could also do it like this where you're doing 1, 2, 3, 4, and 5. So it really doesn't matter how you do it, ladies and gentlemen. The key is making sure that you have 5 valence electrons, either have 2 of them paired up, or you can do it such as the examples that I've shown you on the screen. Group 16, if we just choose oxygen or sulfur or polonium, any of those elements in group 16, they're going to have 6 valence electrons. So I'm going to draw it out. I'm going to put 1, 2, 3, 4, 5, and 6. Again, another way that you could do it: 1, 2, 3, 4, 5, 6. But remember, it doesn't matter as long as you put your 6 around that particular element. Now, what you should be noticing is that as we go from the left to the right of those elements, from groups 1 to group 18, the shells, the valence electrons, the outer shell is filling up. In chemistry, the ideal number is 8. That's known as the octet rule. That means that if I'm going to be satisfied as an element, happy as an element, I must have 8 around it, okay? 8 around it. So that means if I go to group 18 and I choose any element except for helium, they're going to have 8. And if you've noticed, the reason why helium will not get 8 is because helium has 2 electrons. Now remember, valence electrons are not the same thing as electrons. Valence electrons deals with the group number, okay? But it's somewhat related to the number of electrons, somewhat. But you need to keep in mind that because helium is part of group 18, part of the noble gas group, only having 2 electrons, that is the only one that will not have a full shell. But if you choose neon, argon, krypton, xenon, any of those elements, you will see that it has 8. So here we go. And that is a full shell, okay? A full shell. In other words, completion in chemistry for this particular chapter means 8. 8 surrounding that element. Now, I'm going to pause the video and show you how to put all of this together if you were forming a bond. Let's go ahead and do that part. Okay, so say for instance you have H2O, which is water. What you would have to do is first look at each of those elements individually. So you're going to take hydrogen, and you see that you have 2 of those in your formula. You have oxygen, you have just 1. You go by the subscript, and that will tell you what you need to know. Now, you're going to multiply each of those elements by the valence electrons number. So remember how we said that hydrogen is a part of group 1? Well, that means each hydrogen is going to contribute 1 valence electron. But because you have 2 of them, 2 times 1 is going to give you 2 valence electrons. Now for oxygen, oxygen is a part of group 16. So that means each oxygen, well, the only one that you see, is contributing 6 valence electrons. So therefore, you're going to multiply the 1 times the 6 to give you the total number of 6. Now you're going to add those 2 together. You've got 6 plus 2. That's going to give you 8 valence electrons for your entire structure. Now you're probably wondering, okay, so what does this mean in terms of me drawing out this picture to make it look according to putting these dots together. All right, let's go ahead and show you what to do there, okay? So all you're going to do is take each of your elements. You have hydrogen, and remember, you have two of them according to your formula, okay? And then you have one oxygen, and you have 6 pairs of valence electrons, okay? All you need to do is start off with your oxygen in the middle, put the 6 around it, and now remember the octet rule. Any element that's a part of groups 14, 15, 16, and 17 must have 8 around it, okay? So according to the octet rule, any element that is a part of group 14, 15, 16, and 17 must have 8 surrounding it. Those elements typically go in the middle. Okay, so we've got oxygen surrounding 6, having 6 valence electrons, and then what you're going to do is bring in the first element of hydrogen. Now remember, hydrogen has 1 valence electron that it's going to contribute, but you're going to send it to the middle. It doesn't have to be beside it. Remember, you're going to make sure that you bring it straight to the middle element. You're going to donate it to the middle element. So we're going to go ahead and cross out hydrogen because we've dealt with that. We've already dealt with the oxygen. So we have this last hydrogen over here left. So we're going to go ahead and add that hydrogen to this bond and take the valence electron that it's contributing straight to the middle. Now, if you count all the elements, or excuse me, all the number of dots, all the number of valence electrons on that middle element, you should have 8, which also represents this number here, okay? The total number of valence electrons. Now, let me also share with you that when you draw out the final structure in chemistry, we have what's called the Lewis structure, okay? This is the electron dot notation, meaning you have those dots there, but the Lewis structure is identified by replacing those dots with a dash. That dash represents a bond that is attaching to another element. And here you have the structure for water, okay? So you have your hydrogens on both sides, your oxygen is in the middle, and your 8 pairs of electrons all around it. All right, so I said I was going to try to keep this video short, but I also want to show you one more example where you have just 2 elements, okay? So that way you can see how all of this is not as bad as you think. And I'm going to post a link in the description box or up above this video so you can see how I have several other examples just like this one, okay? So let me go ahead and show you one more where you have just 2 elements. Just 2. All right, here we go. All right, so say for instance you have sodium chloride, that's NaCl. All right, go ahead and take your compound apart. You've got one of each. You have one sodium, you don't see any subscripts, so that tells you you have just one. You have one chlorine. So now what you're going to do is multiply each of them by their respective numbers of valence electrons. So I know that sodium has 1 valence electron, so 1 times 1 is 1. Sodium is going to have this just that one little dot. And I know that chlorine is in group 17, so you guessed it, it's going to contribute 7 valence electrons. And so now I'm going to just draw out like a little brief image of what it looks like before I put everything together. Okay, make sure you add those up. And now we're going to go ahead and put our structure in place. You've got sodium, Na, with 1 valence electron. Now I'm going to go ahead and add to that chlorine. And chlorine is going to come in with 7. That's 1, 2, 3, 4, 5, 6, and 7. Now remember, we do not want to leave our picture like this. We're going to redraw it because we're going to show that those bonds in between the sodium and chlorine atom forms a single bond, a dash. And so now I'm going to put my other valence electrons. And in chemistry, ladies and gentlemen, those that aren't attached to anything, we call those non-bonding pairs of electrons. Those non-bonding pairs of electrons will help you out when it comes to determining the shape of those structures. So stay tuned for that. And if you have any questions, just put them below this video.